Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of ECE at K.S. Rangasamy College of Technology. In this lecture, we are going to see about adders and subtractors in the course Digital Logic and Microprocessor under the module Combinational Circuits. So first of all, we are going to see the adders, where half adders and full adder. Half adder adds two single binary digits and generates the output sum and carry. The carry will be the overflow into the next digit of multi-digit addition. So the sum will be represented as A XOR B. Carry will be C is equal to AB. The two input variables are otherwise called as SAGN and ADDEN. The output variables are sum and carry. This is the half adder block diagram where we have two inputs A and B, and sum and Cout are the outputs. And this is the truth table where we have two inputs A and B, so that we can have the four combinations of inputs 0, 0, 0, 1, 1, 0 and 1, 1, and two outputs sum and carry. If the inputs are 0, 0, the output will be sum is 0, so that carry will also be 0. If it is 0, 1, when we add 0, 1, the sum is equal to 1 and there is no carry. When we add 1 plus 0, the sum is 1, there is no carry. When we add 1 plus 1, it is 2 when we convert it into binary, so that we will be having 1, 0. That is 1 and 1 will be added, so that we will be having 1, 0. So this will be sum and this will be carry. The extra bits after performing addition operation of the two bits, and this will be carry. So when we have the truth table for sum and carry, and for next we need to find out the K map for sum and carry. So when we take the sum, we need to take the output 1, for which the input variables A and B 0, 1 as well as 1, 0 will be mapped into the K map, so that it cannot be grouped together. So it will be taken as individual. So it will be giving A B bar plus A bar B, so that this will be the output for the XOR gate. So A XOR B will be the sum using the K map, and C will be calculated by taking 1 in the carry of the truth table, so that the inputs are A and B. So for A and B is equal to 1, the output will be 1. So it is taken as individual, so that it will provide the product term C is equal to AB. So with this sum and carry information, we can draw the logic diagram for the for the inputs A and B. So A and B are the inputs. Sum will be the A XOR B, so XOR gate we need, and C will be A and B, so that AND gate we need. So this is a logic diagram for half adder. Similarly, for the full adder is a combinational circuit that forms arithmetic sum of 3 inputs and it provides 2 outputs. 3 inputs are A0, B0 and C0, and this will be the carry from the previous adder, and it provides sum and carry as output. So the output of first full adder Cout will be given as the input to the carry in for the next full adder. So this will be available here. So truth table for the full adder, where the inputs A, B and Cn, and the outputs are sum and carry. If we have 3 inputs, so that we can have 7 inputs from 0 to 7, and we are getting sum and carry. If we need to add 2 bits from that is A and B will be initially added. Further the result will be added with Cn. So 0 plus 0 is 0. 0 plus, once again the result of A plus B is added with Cn. That is 0 plus 0. So that sum and carry will be 0. And 0 plus 0 is 0. 0 will be added with Cn, that is equal to 1, so that sum will be 1 and carry will be 0. Similarly for 0, 1, 0, 0 plus 1 is 1, sum is 1 and the sum 1 is added with carry, so that sum is equal to 1. What will be 0 plus 1 is 1, 1 plus 1 is added, so that 1 plus 1 we have already seen in the half adder, where when we add 1 plus 1, so we will be getting 1 0, 0 will be the sum and carry will be 1 out of that there will be overflow during addition operation. So similarly for the remaining thing, if we have only one of the three inputs, then we'll be having sum as 1, carry as 0. If we have two ones where we have sum is 0 and carry is 1. What about for 1? What about for 1 plus 1 plus 1? So if we have 1 plus 1, this is 1 0. If we have 1 plus 1, then it is 1 0. And further this 1 will be added with the sum, so that we will be having 0 plus 1 is 1 and this will be 1. We already know that this is carry and this will be sum. So that this will be sum and this will be carry. So that we will be having sum as 1, carry as 1. And next came up and logic diagram for the full adder. So we have already found out the sum and carry for the inputs A, B and C. We need to map all the output 1 in the sum in the K map, so that we'll be getting the sum as like this. When we simplify this sum, we'll be getting A XOR B XOR Cn. And for the carry and when we map the output 1 for which the inputs will be taken into account, then it is placed in the K map, and when we pair the number of ones together, so we'll be having the sum of product for carry out like this. And this is the logic diagram for the full adder. For the full adder, sum is A XOR B XOR Cn and carry is AB ACn plus BCn, AB ACn plus BCn. Similarly for the full adder can be constructed by using two half adders with one OR gate. Half subtractor will be having two inputs and two outputs, difference and borrow. 0 minus 0 is difference is 0 and borrow will also be 0. 1 minus 0 is difference is 1 and borrow is 0. 1 minus 1, difference is 0 and borrow will also be 0. What about for 0 1? 0 minus 1. 0 minus 1. So 0 minus 1. 0 minus 1. We need to borrow 2 from the next bit position, so that 2 minus 1 is 1. We already have this 1 here, so it will be bring down. This will be the difference and this will be the borrow. So borrow and difference will be given here. And wherever we have ones in the output difference, those inputs are mapped into the K map. Will be getting A XOR B as difference and A bar B as borrow. And this will be taken for the drawing the logic diagram. Logic diagram will be giving the difference A XOR B for the inputs A and B and borrow A bar B. And similarly for the full subtractor will be having two inputs, that is three inputs A, B and Bn, and it will be having two outputs. It's like your half subtractor, difference and borrow. So we need to perform the subtraction bit by bit. 0 minus 0 is 0, 0 minus the result of this two bits will be further subtracted with B in, borrow in. So 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 1. 0 minus 1 we have already seen. Yeah, where the difference is 1 and borrow is also 1. 0 minus 1 is, difference is 1, borrow is 1. Difference is 1, borrow is 1. Further it will be subtracted with 0, so that 1 and 1. 0 minus 1 and 1 1, so that this 0 will be subtracted, so that will be having 1 minus 1 and 1. This will be the difference and this will be the borrow. So 0 minus 1, 1 1, further it is subtracted with 1, so that subtracted with 1, 1 minus 1 is 0, so this will be the difference and this 1 will be the borrow. So difference is 0, borrow is 1. 1 minus 0 is 1, 1 is the difference, 1 minus again it is subtracted with 0, so that borrow is 0. 1 minus 0 is 1, 1 minus 1 is 0, so that borrow and difference will be 0. 1 minus 1 is 0, 0 minus 0 is 0 and 0. 1 minus 1 is 0, 0 minus 1, we already know the 0 minus 1 is 1 1. So that's all. K-map and logic diagram for the full subtractor. Difference, when we map all the ones in the difference and borrow in the K-map, so that we'll be getting the differences like this, borrow is like this. When we pair number of ones together, by simplifying this difference, we'll be having A XOR B XOR C. Further, this borrow will be drawn, and this will be giving the full subtractor logic diagram. Thus, like your full adder, full subtractor can also be constructed by using two half adders as well as two half subtractors as well as one OR gate. So with this, we have learnt half adder, full adder, half subtractor and full subtractor. We can have some quiz questions. In a half adder, the sum output is given by, what will be the expression for the sum, and carry output for the half adder is given by, so sum output for half adder as well as half subtractor will be A XOR B. Carry output for the half adder is AB and carry output for the half subtractor is A bar B. How many inputs and outputs does a full adder have? So full adder and full subtractor will be, a full adder can be implemented by using how many adders? How many inputs or outputs does a full adder have? 3 inputs and 2 outputs. Full subtractor also. A full adder can be implemented by using 2 half adders and 1 OR gate. Similarly, the full subtractor will be 2 half subtractors and 1 OR gate. The difference output of the half subtractor is, we already know, seen. In a full subtractor, the inputs are, so the result is A XOR B, and full subtractor will be A B borrow in. So we can have some for true and false. Half adder has 2 inputs and 2 outputs. Yes, it has sum and carry as output, A and B are the inputs. Full adder can add only 2 inputs. No, it is false. A full adder can add 3 inputs. A borrow output for a half adder is AB. False. It is A bar B. AB will be the borrow, that is carry output for the half adder. A full subtractor has 3 inputs and 2 outputs. Yes. XOR gate is used for generating difference in half subtractor and full subtractor. Yes. So that's all about, we have seen adders and subtractors. Thank you for your patience listening.